Probably won't mark you tardy twice. What?
What's your first grade after this class? Wait. After, yeah.
Yeah, you remind me.
Okay.
Or do you know how to get on your phone?
No.
No. Yeah. Okay.
We just do it out in person.
31. So we're supposed to solve the equation for A. It says C equals B squared minus 4AC over A.
More math?
It's a pretty tough one. I think when we did the homework assignment on this, I don't think they gave us one quite this hard. Does anybody want to guess something we could do? We're supposed to solve for A. Good guess, yes. Multiply by 2A. One of the problems is we got A's in two places, but yeah, when we multiply by A, or actually I'm going to multiply by 2A, get rid of all that. Okay, normally when we're solving for like X and there are X's on both sides, what do? We get them to one side, right? So how can I get my A's to one side?
Add 4AC.
Plus 4AC. What's 2AC plus 4AC? Oh, was that squared? Yeah. Okay. How do I get A by itself right here? Divide by 6C. And that goes away, and basically, that's it. 30 is not that much, as much work as that one.
What number is that one?
31. Okay, page 2, 33. Can't see.
I don't get it.
Okay, on 33, what should we do first? Distribute. So, some of you might have gotten this one wrong because when it says minus, actually that's kind of like number, what number was that? 20? On number 20, you're supposed to subtract everything in the right parentheses. On 33, you're supposed to subtract everything in that right parentheses. Okay, we're subtracting the parentheses, not the 6x. So, on the first parentheses, when we distribute, we get 4x plus 8. And then we're supposed to subtract from that 6x plus 9. So that means subtract 6x and subtract 9, both of them. So 4x minus 6x is negative 2x, and 8 minus 9 is minus 1. And on the right side, oops, not equals, it's greater than 19. This section does say graph your answer, so we're going to do that. Now we got a normal problem. Just going to do the normal stuff. Plus 1. What do I have to remember when I divide by negative 2 here? Well, the inequality switches, right? So it becomes x is less than negative 10 instead of greater than. Okay. So, guys, on this one, what would I do to solve for x? Does the inequality switch? No. Okay, because I divided by positive 2. On this one, I divided by, it doesn't matter that 10 is negative. That doesn't matter. It's what you divide or multiply by. If you divide or multiply by a negative, it does switch. How do I graph x is less than negative 10?
X arrow going up. Wait.
Is the circle open or closed? Open, going less than left. Okay, 35 is just two separate things. This is Monday's assignment. A lot of us got the graph wrong. Probably most of us got the graph wrong on these. So I want to pay extra attention here. So 4x plus 5 is greater than or equal to 4. I guess I'll just write it down. Should go without saying that you need to show work. Some of you didn't, like, somehow magically got an answer with no work on some of these problems, and I did not give you credit. Most of you did show work though, so. Yeah, I just copied it down. 3x plus 1 is less than 2. Did I copy it right? Sometimes I copy the wrong thing down. Yep, okay. Just making sure. And this was an or, wasn't it? Yeah, it was an or. Okay, again, when it doesn't divide well, one divided by 3 doesn't work very well, so just leave it as 1/3. Okay, this was the part that most people were getting wrong. It is tricky. Where is negative 1/4 on the graph?
Close to 0, just a little bit behind it.
Right, a fourth of the way to negative 1, so about right there. And 1/3 is a third of the way to positive 1, so it's right there. Yeah, I probably shouldn't have put those dots there, but that's where they are.
When's the line on the right being opened?
Okay, no, we're not graphing yet. So what you have to do is, first off, when you have two different inequalities and you're combining, we put the floaty lines above the graph, and then our final answer goes on the graph. So greater than or equal to negative 1/4, right there, would look like that. Less than 1/3 would look like that. Yeah, that's about right. Close enough. Okay, but how do they combine? If they're an or, what are we going to use? Everything. Okay, should I draw any circles down here? No, because we're using everything. It doesn't matter that that's an open circle, because it's being included in this other line. So anyway, it's just a solid line. When you draw your lines, draw them either really thick or above the graph, so I can actually see them.
I didn't know we had actually lines above. I thought that you were just doing that to, like, show people.
This is kind of my work to figure out the answer. The answer is basically all real numbers on this one. So, right, it's a fancy R. I graded the paper on this part up here, like half a point for this, half a point for this, and half a point for this final thing. Most of you missed the final thing on that problem. That type of problem. Mondays was a hard lesson. That was definitely the hardest one we did this chapter. 37. This is Wednesday's assignment. Less than. This is kind of a challenge too, I guess. What should we do first on 37?
Where's the 19?
Minus the 19. We want that absolute value by itself. So if I subtract 19, I get 2 on the right. Whew, 39 is a doozy. 39 is a doozy. Okay, so this part we did pretty poorly at too, actually. How do we set up less than with absolute values? Yeah, some of us know. Yeah, when it's gonna be, 5x minus 6 is gonna be between two things. 2 over on the right and negative 2 on the left. So that's what it looks like. When we solve for x, we're trying to get x by itself in the middle. How do I get x by itself? Plus 6. So there's 3 things now that we're plusing 6 to. The middle, just to get rid of it, and then the left and the right. Still have a 5x in the middle. Hey Dylan, I'm not blocking your view today. I'm standing on the right there. No, your guys left. Huh?
So you're blocking art?
No, I'm not. Just when I'm writing, but that can't be helped. Okay. Now what do I do? Divide by 5. So those don't divide by 5, right? 4 divided by 5 is just 4/5. 8 divided by 5, 8/5. They don't reduce either. And that's it. That means x is bigger than 4/5 and smaller than 8/5. It's all the numbers between. 8/5, by the way, is like 1 3/5. So when we go to graph it, this should work. Should these be open or closed circles? Open. So 4/5 is about right there. 4/5 is the way to 1. 8/5 is 1 3/5, so that's about right there. And you just x is all the numbers between those two. That's why it's in the middle here. So you just connect the circles.
On 38, there's a 3 minus the total x plus 2.
All right, what do you guys think we should do first on 38? Minus 3. What about that negative? Well, so you subtract 3. What about this negative?
Makes everything the absolute value negative.
No, you can't use distributive property on absolute value.
I don't think you could pick.
Like a -1 right there, right? So what are we gonna do with the negative?
Then add 2.
It's like divide by -1, divide by -1. This is multiply. When it's right next to it, just like right next to parentheses, it means multiply. But we can't distribute it because it's absolute value, not parentheses. Absolute value does what it's done. So you just divide by -1, you get. Okay, but I did something wrong.
It needs to be greater than rather than less than.
Needs to be greater than 2, not less than. Okay,
So then
on number 37, the one we just did, it was a less than. This problem is an absolute value greater than. This is the one that separates into 2, just like the equation that we did yesterday, where it breaks into 2.
So if they're greater than or
Okay, by the way, people get confused when we do these because if this was just a greater than with no absolute value, all you would do is subtract 2, okay? But if it's an absolute value greater than, you have to split it. It's either x plus 2 is greater than 2, or x plus 2 is less than -2. kind of like the equation we did yesterday. You split it in two. And then you solve both of those, and then you graph both of those on the same graph. Should be arrows going out, if you did it right on the graph. $39. Save the best for last. What do you guys think we should do first on 39?
Add 9. Get rid of the 2x.
And minus 2x. We got to get that absolute value by itself. So when we add the 9 to the right, negative 3 plus 9, it becomes a 6. And we minus the 2x. So we got minus 2x plus 6 on the right. And x plus 3, absolute value on the left. Let's see, it was negative 2x plus 6. Okay, kind of like what we just talked about. It's an absolute value greater than problem. And how do we set up greater than? Set it up as two separate ones, right? So we got x plus 3 is greater than negative 2x plus 6. Or
Positive.
x plus 3 is less than, what do you guys think? 2x minus 6. Good. You just switch both the signs. Because we're supposed to make the right side negative when we do that. So we just switch both. Negative 2 became positive 2, negative 6. Okay. And then how do we solve it? So we got two separate equations. Okay.
Get rid of the
Add
These
2x.
do not touch these.
Add 2x to all those things.
Right. If we have x's on both sides, we need to get rid of them. So add 2x. We got some normal stuff here.
Wait.
Did I make a mistake?
No, I did. I'm so silly.
You are silly. You're silly Billy. And how about this one? Let's see. Let's do what? What do you guys think?
Plus 6.
Okay, probably should do the x's first so we know which way we're going. Minus 1x, could minus 2x, but it might be less confusing to minus 1x. If we do that, it says 9 is less than x, which is the same thing as x is greater than 9. I'm going to go ahead and write it that way because it'll probably be less confusing for us. We keep the x over there. And the graph. These are kind of far apart, so I'll just put 1 and 9. I don't care about all that graphing in the middle. So, floating lines first. X is greater than 1. All the way across. X is greater than 9. All the way.
So it's just.
Okay, if it's an or, what do we use? Both. So in other words, this. Do I need this circle right here? No, because it's covered by the other line. So really, the simplified answer is just x is greater than 1.
Okay.
That's what an or does. You can use that one or that one. You use both. If it's an and, you have to use it where they're both at. It has to be this one and that one together.
That was a doozy.
That's like the next one's fun to look at.
Yeah, that section's kind of tough.
See how it sounds?
All right, 41. Write an absolute value equation or inequality. Oh yeah. I might skip these actually because we didn't really do much with that. We did 40 on the homework, but yeah. Guys, stop goofing. Pay attention. We did 40 on the homework, so yeah. Let's just jump to the word problems. We'll skip those.
So, don't.
Carson probably will have no clue.
So do we just need to assume my phone?
Hmm?
Do we just need to assume my phone after?
No, that I'm saying you don't have to do them. But I do want to do those word problems though. So 44.
Wait, question. So
Okay, actually, guys, in the next like 30 seconds, I will try to write an equation or equations to describe what 44 is saying. Just give it your best shot. It's okay if it's wrong. We'll fix it if you need. 44. Try to write an equation to describe what they're saying. Or equations. No. Did you try? Write an equation or equations to help with 44. Mason, did you try? Try. Says find three numbers whose sum is 54. That's an equation. No. It's not an equation you can solve, but it is an equation.
Oh, is it the, n plus 1?
Okay, let's see how you guys did. I didn't mean for you to solve it right now. I meant for you to just write equations right now. So, what does sum mean? Add. What are we adding?
three numbers that add.
What should I put in for the three numbers?
X, 2x, and then 2x minus 6.
Okay, for now, I'm just going to call it A, B, and C. So, three numbers that add up to 54. Okay, that's equation number 1. Then it says 50, if the largest number is, what did is mean? Equals. So I don't really know which of these is the largest, so you just got to say, let's let A be the largest or something. Doesn't matter as long as you're, yeah. So let's pretend we know A is the largest, B is the middle, C is the small. We'll say that. So it says the largest number is twice. What does twice mean? 2 times the smallest. And I said I'm going to let C be the smallest. Okay, let's keep going. That's the second equation. Then it says,
C is A divided by 2.
then it says the other number, the number we haven't used yet, B, is, that's your equals, 6 less than, what does 6 less than mean? Minus 6. 6 less than the largest. We said A was the largest. So A minus 6. Okay, we got a little bit of a problem here. So we want an equation that only has one variable. I can't solve a 3-variable equation because if A is something, B could be something else. Can't solve a 2-variable equation. You need a 1-variable equation. So if I put like A minus 6 in for B, this and this would be turned into A. These would be A's. But,
And A equals 2.
right. I need the C to turn into an A. I can solve this for C if I divide by 2, right? A divided by 2 is equal to C. Now I've got something that I can put in for C that turns it into an A. You guys get it? So this top equation would be A plus, turn it into A minus 6 plus A divided by 2. Or you could think of it as 1/2 A.
Well,
What is A plus A plus 1/2 A? 2.5 A. Or maybe just to make it easier for ourselves, we'll call it 2.5 A. 2.5 is 2.5. And now we've got a pretty basic equation, don't we? Plus the 6. Divide the 2.5. How many times does that go? 24? Is that right?
But then we have to find the other variable.
Okay, yeah, once you find one number, A in this case, the big number is 24.
24 minus 6 is B.
To find C, you can do 24 divided by 2 equals C. To find B, you can do 24 minus 6. So you just plug A in to these to find B, C and B. As long as you did it right, it doesn't matter. Isn't this basically what you said? Right here?
I just used X instead of A.
Oh yeah, well, the letters don't matter. I just think A, B, and C are prettier than X, Y, and Z.
I didn't know.
Mine's not that hard. Once we got the formulas down and the word problems, it was not that
Wait, so what was the B? What part did you solve?
I didn't do B and C, that's up to you. All right, on 45, it says a train heads south. Okay, before I even read anything else, what kind of problem is this? Arrows, distance. Instead of each distance, what did we put on these problems? RT. Distance equals rate times time. So each distance is going to be represented by a rate and a time. But as we read this, the first thing you should think of is, what do the arrows look like? Okay, let's think of that first. A train heads south out of Bloomington 1 hour after a northbound train leaves Bloomington.
So we have.
Okay, that's enough for the arrows.
So just the arrow going right and there's no one minus.
Well, normally we say on a map, north is that way and south is that way, so I'll use up and down. So 2 trains are leaving Bloomington, one going north, one going south. That's what they told us. So it should look like that. They're not telling us the distance of that each train traveled. So each train is going to get a rate and a time. I'll just put it over here, I guess. What are the rates and times? Well, let's start over again and read what they tell us. A train heads south out of Bloomington 1 hour after the northbound train leaves. Okay, this kind of confuses people. If you leave an hour later than somebody else, have you been traveling a longer time or a shorter time than somebody? Shorter. So the southbound train left an hour later, so their travel time is shorter. So I'm going to call their time, guess what? T minus 1. I'm going to call the northbound train's time T. If you leave an hour later, you actually have been traveling an hour shorter than whoever else left. So the southbound train got T minus 1. What else does it say? The northbound train's going 63 miles an hour, southbound train's going 57 miles an hour. Where do I put 63 and 57? That's the rate. Was northbound 63? Okay, so that one gets a 63, southbound train. You guys see what I'm doing? I'm just replacing the R's and the T's with the, whatever they tell me. Okay, we need one more fact. They tell us also, well, the question is how long, so how much time will each have traveled when the trains are 243 miles apart? Where do I put 243?
Equals.
Okay, that's from there to there, all the way across. So I have three distances. The northbound train's distance, the southbound train's distance, total distance. What's the relationship between these three? What do you think,
They
Gracie?
add up to equal, right?
Yeah, it's, their distances together should equal the total distance, right? So that one plus that one equals that one. This plus this equals this. So anyway, 63t, the pictures just help us get here, plus 57t minus 1 equals 243. Yeah, and then you do normal algebra stuff. What are we trying to get to though? What did they ask us?
How much time was traveled?
So will t give us that answer? T describes the northbound train's time, so t is half of the answer. How do I find the southbound train's time?
So then we're gonna have to subtract
T minus 1. So t gives us the northbound train's time. Subtract 1, that's the southbound train's time. I'm going to let you guys finish that. Solve for t. Should be two answers.
Oh, no, no.
Distributive property first. How are we doing on time?
10 more minutes, I think.
Maybe, let's see, how far did I, 49, that was ambitious.
It's 46, later about.
Yeah. Oh, yeah, you're right, I was looking up here.
Silly Willy.
Silly. 46 it
Oh,
says.
God.
There's one more.
Yeah. Oh, wait, we're doing it too. We just did 40.
0.0149948.
Well, I was gonna help you set them up, but let you solve them, yeah. Yep. Last one. Yeah, there is fraction. Yeah, there is a fraction or a decimal or,
Wait, you said there's two answers?
yep.
Where, how do I get the second answer?
Trevor, what are you doing when I'm talking?
I got T, I'm paying attention. I just don't get-
Really?
Yeah,
'Cause I said it like 3 times.
I got T.
T is the northbound train's time. T minus 1 is the southbound train's time.
So
Yep.
we just find out what this one?
Plug it
Yeah, so
in.
it's.
For T.
Hmm. All right, 46, you guys ready? Okay, Dave has $3,000 more in a money market account. That's just an investment thing. I don't even know exactly what it is, doesn't matter. Then in his savings account. Pay attention. Okay. So actually that's kind of an equation. He has 3,000 more in his money market, So is his money market higher or his savings account higher? Money market's higher. So his money market is equal to 3,000 more than his savings account. That's an equation. S might not be the best letter to use because why? It's like a 5, but as long as we're careful, it'll be okay. Yeah. Who left? Megan left, or comes back. Unless it's like an emergency. Huh, he snapped it. Okay. Yes, very funny. So the next sentence says, the savings account pays 0.5%. Okay, this might confuse us. Do you guys know what 0.5% is as a decimal? Yeah. Remember how we moved it twice to turn it into a normal decimal? So it's 0.005. Okay, and the money market, that's for a savings account. It's probably about right. Some of you have a savings account? You probably get less than 0.5% per year. So you, yeah, probably 0.1 or something tiny like that. But better than nothing. It says his money market account gets 2%. What's 2% as a decimal?
0.20.
Right, so the decimal moves twice, 0.02. We'll need those for later. How much is invested in each account if the annual interest that he earns on the 2% is 180 more than the 0.5%? Okay. The money that he gets from his money market is going to be 2%, they told us. So 2% of the money market, they told us that is greater than, how much greater than? They told us that number is going to be 180 more than the 0.5% on his savings account. That's why you don't want to use that S right there, but we did it anyway. So the money that he makes from the money market, the 2% from the money market account, is equal to 180 more than the 0.005 that he makes from the savings account.
Equals 3,000.
So yeah, what trick do we use? Now we got two equations. What trick do I use to solve? Substitution. M equals all of this.
So
So we can put that in for M right there.
Times 3,000 plus S.
Yeah, that is an S, not a 5.
It is now.
Distributed property.
Okay, now we have a one variable equation that we can solve. Yes, distributed property. Once you solve for S, that's a savings account, plug it back into one of the other equations to find M. Okay, solve for S, plug it back in to find M. 2 answers. Okay, that was our last problem, so I'm just going to give you guys some time to work.